All right, so here we go again. So let us now continue with our discussion on the soil classification. So we have just discussed on the soil taxonomy and the purpose of classifying soils and what are different requirements in soil classification and soil taxonomy. So we made mention that it requires us to know the temperature, the moisture regime, the mineralogy, and all this concept that we have just discussed. And now, today, so let us continue the with those requirements. No, we will continue with the different requirements for classification, soil classification. So ito yung kanina, no? Ito yung sinabi natin na, sorry, kamali. Ito yun. So ito yun. So, ito yung mga requirements, no? When we are to classify soils, we have temperature regions, moisture region, diagnostic horizon, ano yung nasa A horizon, ano yung nandun sa subsurface horizon, mineralogy, particle sizes. Now, now let us look at first the soil temperature regime. So, ano yung mga different soil temperature regimes doon sa control section measured at 50 centimeter from the ground surface? Okay, so we have what we call pergelic, no? One of the soil temperature regime is pergelic. So what is this? The main annual temperature measured at 50 centimeter from the ground surface is less than 0 degrees Celsius. So look at this sign. No? When so less than dito sa right, sa left side ng ating braso is this is less than and this is greater than sa too. No? Greater than, less than sa wala. All right. So pergelic, the main or the average yearly annual temperature at the control section is less than 0 degree Celsius. Pag kinuha natin yung temperature doon sa critical control section, which is the measured at 50 centimeter from the ground surface, pag less than 0 degree Celsius ang average annual temperature ng section na yon, that belongs to a pergelic soil temperature regime. So take note for that. Pergelic, less than 0 degree Celsius. Maybe negatives, no? There are -1 or below 0. Another soil temperature is cryoic, when the main annual temperature is between 0 degree Celsius up to 8 degree Celsius. So take note for that. The same, no, temperature from the soil control section. Excuse me. Another soil temperature regime, frigid. So when the main annual temperature is less than 8 degrees Celsius, warmer than cryoic in summer. So if it is warmer than cryoic in summer, then it is frigid, less than 8 degree Celsius. So basic ang temperature ng control section ng soils if the main annual temperature is 8 degrees Celsius and up to 15 degree Celsius. So yan. And another is thermic, or the main annual temperature is within 15 degrees Celsius up to 22 degrees Celsius. Okay, and the last one, and the last one is hyperthermic. When you see hyperthermic, it is higher than thermic temperature. Okay, so hyperthermic is higher than thermic. When the main annual temperature is greater than, so this is greater than sa tuong side, sa kanang bahagi ng ating kamay, braso. So the main annual temperature is more than 22 degrees Celsius within the control section. Okay, so take note for that. Well, please find your convenient way of memorizing this one in order. So maybe you can have your acronym. So you can organize your acronym in here. You can do a ano per crypt. No, you can do a per crypt mitihay. You can do that per crypt mi hype. So per crypt miti hype. So you have pergilic, cryic, per crypt F frigid, misic, T thermic, hyperthermic. So you can have your own code for that. You can have your own what's this acronym for that you can decode later on, because it is important to memorize this one, because in previous exam may lumabas na mga ganito. So please memorize this one. And how are we going to use this one in naming soils? No, makita natin later on. Okay. So that is for soil temperature regime. So to continue, so yung mga soil temperature regime na yon, we have to add a prefix ISO. So dagdagan natin ng ISO. Prefix ISO is used if the mean summer, so the summer in the Philippines, you have the June, July, and August. If the mean summer and the mean winter, which is December, January, and February, differ by less than 5 degrees Celsius. Again, you have to use the prefix ISO if the mean summer and mean winter temperature differ by less than 5 degrees Celsius. Now, if in the same control section, kung ang temperature niya sa annual temperature niya sa summer compared to annual temperature niya sa winter would differ by less than 5 degrees Celsius, then we have to add a prefix ISO. So for example, so isoprigid, no? Sa isoprigid, the main annual temperature ng isoprigid is less than degree Celsius within that control section. Okay. Kung nag-vary ang temperature ng summer and winter of less than 5, but for example, ang temperature ng summer is, shall we say, 5. And then the temperature ng winter is 7. Therefore, the difference is 5 and 7 is 2. That is less than 5. Therefore, ang tawag natin sa soil temperature regime na yon, because it has a difference of less than 5 degrees Celsius between summer and winter, and ang yung main annual temperature is less than 8, tawagin natin isoprigid. So, ganun yan. So, ganun din, kung misic, so ang misic is, the temperature is, ranges from 8 to 15 degrees Celsius. But if the difference between the summer and winter, and it falls within 8 to 5 degrees Celsius, it's misic. If the difference is less than 5, then we have to call it an isomisic. Okay? And then ganun din, no? Isohyperthermic, kung ang difference between summer and winter of the thermic temperature is less than 5, then we call it isohyperthermic. Ganun din, isothermic. If the average temperature in the entire year is less than 22, but the difference between summer and winter is less than 5 degrees Celsius, then, sorry, if the temperature of the entire year, an average of that particular control section is more than 22 degrees Celsius, but the difference between summer and winter is less than 5, then we have to call that temperature regime as isohyperthermic. So meaning to say, all we have to do is just to add a prefix iso when the difference between summer and winter temperature of that particular soil temperature regime varies by less than 5, then we have to add an iso prefix, such as for this particular example. Okay? So please try to understand this one because posibleng lumabas ito sa board exam. Okay, so let's proceed. Okay, so when we have a soil temperature regime, we also have a soil moisture regime. Okay, ano yung mga moisture regime na yan? So, soil moisture regime measured in terms of absent or presence of water held at a tension of less than 15 bars in the moisture control section by a period of 1 year. Again, soil moisture regime is measured in terms of the absence or presence of water held at a tension of less than 15 bars. So, bakit 15 bars ang i-consider? Because less than 15 bars, because greater than 15 bars or beyond 15 bars, the roots cannot absorb the soils, the roots cannot absorb the water that has been held in the soil surface of more than 15 bars. So ang kaya ng tanom, kaya ng plants to absorb water, plants can absorb water from the soil surface if it is held by less than 15 bars. So more than 15 bars cannot be absorbed by the plants anymore. It's beyond their capacity to absorb water. So ang water greater than 15 bars, dili na magamit. So waters held beyond 15 bars, maybe that particular soil is dry. No? Although there are some waters in there, that the water cannot be absorbed by the plants because it's strongly held to the surface of the soil. Again, soil moisture regime measured in terms of the absence or presence of water held at the tensions of 15 bars in the moisture control section by a period of 1 year. So take note for that. Okay, the soil control section. So unlike doon sa soil temperature regime, the soil control sections of the soil temperature regime is 0 to 50 centimeter. But soil moisture regime, the control sections varies according to different types or different types of soils. For example, soil moisture control section for soil moisture regime of clay soils, if the clay soils, the control section should be within 30 centimeter up down to 10 centimeter for clay soils. Okay. So why is this so? Because yung mga clay, it will hold waters longer than compared to sandy and silty soils. So ito yung mga control section ng temperature, moisture in the clay soils. What about in loamy soils? So the control sections for soil moisture regime for loamy soils is within 20 to 60 centimeters depth. Okay, for loamy soils. And for sandy soils, so we are to consider a depth of soil control section for moisture regime from 30 to 90 centimeters. Why is this so? Because water in sandy soils would easily drain and percolate downwards That's why you have to apaso na to ang tubig kay to na siya sa lawom, nahulog na siya, no, parang ganon. So but the point is the soil moisture control sections varies according to the different types of soil texture, because clay, loamy soils, and sandy soils, silty soils, these are soil textures. So take note for that. So what are those different soil moisture regime? So we have the aquic moisture regime. The word aquic or aqua, we're talking about water. Okay, what is this? So aquic moisture regime, soil is saturated. Okay, it is saturated. The pore space or the pore space of the soils has been completely filled up of water. So I mean to say the soil is saturated and no dissolved oxygen. This is the reducing regime, meaning to say no oxygen. So no dissolved oxygen. Katulad ng, for example, if we have an empty bottle, if that empty bottle has no water, therefore it is completely filled with oxygen or air inside in it. But if that bottle of water is completely filled with water, then therefore no air in it. So the relationship between water and air, if there is a full of air, then there must be no water. And when the water is filled in it, then the air has to displace outside, thereby filling the bottle with full of water. So aquic moisture regime, saturated, meaning to say puno, puno sa tubig ang atong yuta diha, no? Okay, usually these waters are of submerged soils kana sa mga palayan natin sa paddy area sa basakan, no? Ganun. So another moisture regime, we have acidic and turic. So acidic and turic. So what is this? Soil moisture control sections is dry. This is dry. Soil moisture control section is dry more than half of the time when soil temperature at the 50 centimeter is less than 5 degrees Celsius. Moist for less than 3 months only. So moist for less than 3 months only, and the rest are dry periods. So take note for that. So I guess we have to change our the color of our printer because parang mag-contrast siya sa ano. I guess yellow is good. All right. So another, we have the ostic moisture regime. Okay, what is this? Ostic, dry more than 3 months. Okay, the soils dry more than 3 months and continuously moist for at least 3 months. So dry for more than 3 months, then moist for at least 3 months. So kung basa man siya ang lupa, so pinakamataas ng basa doon ang 3 months. But ang dry period niya is more than 3 months. So this is the ostic moisture regime. So ito yung mga lupa sa mga maiinit na lugar. Okay? Another, we have the odic moisture regime. So what is the odic moisture regime? So soils dry for less than 3 months only. So less than 3 months only. That's odic. You know, look at the spelling. Odic moisture regime. Dry for less than 3 months only. Okay. Another moisture regime, we have the xeric. We have the xeric moisture regime. So what is this? Xeric is continuously dry 45 days after summer. So after summer, 45 days after summer, dry pa rin siya. And continuously moist 45 days after winter. So this soil is dry after summer and wet after winter. So 45 days after summer, dry. Then 45 days after winter, moist. So these belongs to acidic moisture regime. Okay, take note for that. Again, the same with the soil temperature regime. You have to develop your own acronym in here to aid your memorization. Okay, then you can share your acronym, then you can decode later on. So I suggest that for a group, we must have a uniform acronym for this to aid or easily recall and memory. Okay, so try to do that. We have aquic, aridic, we have ostic, odic, silic. Well, apat lang ito. 1, 2, 3, 4, and 5. So, kung mahirapan kayo gumawa ng acronym nito, so ang gawin nyo lang, memorize the first one, then the last one, then dalawa sa gitna. Ganun ako mag-memorize. So, try to develop your own technique for memorization that you can recall easily later on. Okay, so that's it. So yun, no? We have soil temperature regime, and we have the soil moisture regime. And take note the control section for the moisture regime, which varies with the control sections for the temperature regime. Okay, control section varies. So another important characteristics to be studied when we are to classify soils is the diagnostic horizons. Diagnostic horizons. Ano yung mayroon o makita natin sa horizons? Ano yung mayroon sa A horizon? Ano yung mayroon sa B horizon? Okay? So there are some examples in here. You have the diagnostic subsurface horizon or the Epipedon. Example of that, we have the molic, ombric, histic, and ocric. But what are those? No, these are the basic features. These are the basic features that we can observe in the surface or in the A horizon. Ano yung mayroon sa upper portion, the surface horizon? Ito yung usually na makikita natin. But as to what are these concepts, so you have to deal that on the succeeding discussion. But so if we have a surface horizon or the epipedon, we also have a diagnostic subsurface horizon. So ano yung makikita natin doon sa subsurface? Maybe on a B and part of a C horizon. No? Ano yung mayroon doon sa mga makita natin sa mga horizon na yon, subsurface? So posibleng may makita tayo doon mga argillic subsurface diagnostic horizon, maybe mayroon tayong natric as a short understanding of argillic. Argillic is more on clays, natric is more on sodium, spudic, maraming accumulation ng spudic doon. Oxic is oxides, cambic is lime. Minsan meron tayong subsurface diagnostic horizon na wala tayong makikita. No? These are just among the examples of the diagnostic subsurface horizons that can be observed in the diagnostic subsurface horizon. But marami pa mga examples. These are just a few. No? Okay. So, itong mga argillic, natric, spudic, oxic, cambic, talagang hindi natin ito makikita sa surface or epipedons. Hindi na ito makita. Ganun din, ito ding mga subsurface epipedons, itong molic, ombric, histic, and ocric is cannot be observed in the surface horizon. So, di na ito makita ang epipedon, kining molic, ombric, and histic, di na ito makita sa subsurface. Kini pong argillic, natric, spudic, oxic, and cambic, dili na ito makita diri sa surface horizon. Okay? But what are those? No? What are those? Well, first, okay. So we have example in here. So we have, for example, soil taxonomy. So diagnostic subsurface horizon. So ano yung makikita natin? So I would like to emphasize the subsurface. Ito. So tingnan nyo, sundan nyo itong aking cursor. So iba yung kulay sa taas kumpara dito sa kumpara dito sa baba. So this one is the surface or the A horizon. Mayroong mulik mayroong mulik na Epipedons. So itong A horizon, we can observe na although mayroong diffuse ng A of B, so makita natin is mayroong mulik Epipedon dito. What is mulik Epipedon? It is a thick, dark. So this is a thick, baga siya, no? Thick and dark color compared to the color below. So mas darker ang taas, lighter ang sa baba. So this is a thick, dark, thick kasi medyo malapad siya. So thick, dark, soft. And this portion is medyo less dense, less compact, humok siya, no? Hindi siya matigas. Okay? Soft surface layer. So this is thick, dark, soft surface layer found in A horizon. Therefore, is considered as a mulic Epipedon. Now, knowing of the different diagnostic features in the diagnostic horizon would help us to classify soils based on their soil order. Okay, in this particular example, if we can observe a mulic Epipedon in a surface diagnostic horizon, eventually that soils belong to a soil order of mollisol. Again, so the distinguishing feature of the soil order mollisol is a mulic Epipedon. So whenever we can observe mulic Epipedon in an A horizon, then eventually we would classify that soils belongs to a soil order mollisol. So kasi mayroon ding mga soil order, no? Later on, discuss natin yan later on. So ano yung characteristic ng mulic Epipedon? Yes, sinabi doon, thick. Ang thickness niya is greater than 10 inches. So this one, probably, this portion is greater than 10 inches. Okay? And another characteristic niya is high base saturation. Pag sinabing base, as opposed to it, in contrary to acidic, so basic and acidic, so high base saturation. High base saturation of more than 50%. Pag sinabing mga base, we're talking about cations, mga basic cations or alkaline cations. So we're talking about calcium, magnesium, potassium, ammonium, or any basic or alkaline cations for that matter. So okay, maraming mga base dyan. So hindi siya acidic kasi marami siyang base na more than 50% ang base saturation niya. On the other side, mas gamay iyang acidic cation saturation. So maraming base dyan, maraming calcium, magnesium, potassium, ano yung mga basic cations na meron dyan? Marami doon. So gamay lang diha ang aluminum, gamay ra po din ha ang iron, ang hydrogen. Kay mga acidic man ang hydrogen, iron, and aluminum. So wala kayo sila sa mulic Epipedon. Kay mostly basic cations ang meron dyan. Okay. And of course, the mulic Epipedon is a mineral horizon. Anong ibig sabihin ng mineral horizon? It is a mineral horizon because this mulic Epipedon is derived from rocks and minerals. So therefore, if it is derived from rocks and minerals, their parent materials is rocks, then it is considered as a mineral horizon. If the parent materials belongs to an organic source, it would not considered as a mineral soils. It would be considered as organic soils. So take note for that. And usually, itong mga mulic Epipedons or mollisols, soils form under the prairie vegetation. Pag sinabing mga prairie vegetation, we're talking about the grasslands, no? Na yung mga damuhan dati. Okay? Ganun. So, take note for that. No? This is the A horizon, the darker portion. Merong mulic Epipedon, then mollisol. Then sa baba is the subsurface. So we cannot observe a mulic Epipedon in a subsurface, only in the upper surface horizon. So another diagnostic surface horizon is the ombric. Ombric. Okay. So ombric, it is like mulic, but low base saturation. So in terms of dark, thickness, and softness, the same with the mulic, but what varies is the chemical composition, because compared to molic, it has now a low base saturation. If the molic has a more than 50% base saturation, then ombric is definitely not more than 50% base saturation. Okay, ganun. So take note. We also have histic. Histic from the word organic soils, saturated with water, and more than 20%. This is 20%. So take note ha, kamali, wala hindi nasulat. Hindi nasulat. 20% organic matter. So this is not a mineral horizon because it is from organic source. So this is histic, organic soil saturated with water, more than 20% organic matter. So the country organic matter. Okay. If you are to look at this layer, maybe in this not that visible, but dito because we're talking about histic, there are some organic soils in here. Shall we say humus, no? Mga decomposed or partially decomposed debris of plants. Siguro meron pang mga twigs ng or branches ng grasses and any sorts of plants, no? And trees. Meron pang mga undecomposed or partially decomposed leaves dito. Histic ito, no? So saturated with water. So meaning to say, this has been submerged in water because when organic matter submerged in water, it will not decompose. It will remain as tissues or partially decomposed tissues. Okay. So another Epipedons is an ocric. So ocric, it is a thin. So medyo manipis lang. Look at this one. Okay. Pataas, no? Pataas. Yung portion ito. Okay. This is thin, light colored surface layers that do not fit to any of the above. Hindi siya ocric, hindi histic, hindi molic, hindi ombric. Then it must be an ocric. Okay. So we have example in here. So the name of the soils, we have the udalp. So ang soil moisture regime nito is odic and belong to the order Alphisol. So we have to deal that clearly on the next topic. So far, so those are different surface Epipedons, Diagnostic Surface Horizon. So in sort of summary, so we have molic Epipedons, thick, dark, and soft with more than 50% base saturation. Compared to molic, if it is lighter in color and thinner in the surface of organic matter, then that must be ocric. Compared to molic, if it has more than 20% organic matter, then that must be histic. But compared to molic, if it has a low base saturation, it must be an ombric. So this is how we memorize, how we understand, so that we can easily understand the different surface diagnostic horizon and A horizon. I also included in here the key to Epipedons into taxonomy, no? So that if we are to classify soils based on soil order and diagnostic horizons, so is it a mineral soils? If it is a mineral soils, then it has the thickness of more than 50 centimeter in the Epipedons due to manure application. If having manure application na abono, nag-abono ta because of the human action. If it has a thickness of more than 50 centimeters due to a manure, yes, then that must be called as a plugin diagnostic horizon. If the thickness is more than 50% due to manure application, no. If the horizon is high in P2O5 or phosphorus, if it is more on phosphorus because of human application to the field, then that must be an anthropic. Anthropic now is the accumulations of phosphorus in the A horizon, anthropic horizon. So ganun ang pag-analyze, no? Is the horizons high in P2O5? No, kung dili siya daghan og phosphorus. Is the horizon dark enough to be amulic? Kung dark siya, is the base saturation more than 50%? Then it must be amulic. The base saturation is not more than 50%, then it must be an ombric. So going back in here, is the horizon dark enough to be amulic? Kung dili siya dark, it must be an ocric. Okay? So for example, it is the mineral horizon. No, it is not a mineral horizon. Is that saturated for 30 days? So submerged na siya sa tubig na submerged for more than 30 days? Yes, if it is submerged, then it must be histic, more than 20% organic matter. Saturated for 30 days? No, it must be a holistic. So this is how we aid ourselves in categorizing soils in a different diagnostic horizon. These are example of diagnostic horizon: plagine, histic, polistic, antrophic, ombric, molic, and ocric. So try to understand this illustration, because this will help you in differentiating different diagnostic horizons compared to the other. Okay, let us proceed now. Now, we also have the diagnostic subsurface horizon. The one we discussed a while ago is for surface horizon. Now is for subsurface horizon. Anything that we can observe in the B horizon and as well as in the C horizon. An example of the diagnostic subsurface horizon is the argillic. When we say argillic, we're talking about the alluvial. When we say alluvial, double L, take note for that because there is an alluvial na single L. Alluvial deposition, ang other term na deposition or accumulation. So when we say argillic, this is an alluvial horizon of clay. So there is a clay. Pag sinabing argillic, we're talking about argillans are clay. So mean to say, there must be a clay deposition in the B or in C horizon. So for example, this is the B horizon. BT is a connotation or presentations. BT is refers to argillic horizon or the alluvial or accumulation of clay in the B horizon. So look at the BT. Whenever we see a BT presentation in the horizon, it talks about the accumulations of clay in the subsurface horizon. Okay, so another one, we have the natric subsurface horizon. So natric, this is the same as argillic. There's a clay accumulation in here, but with more than 15% exchangeable sodium. Okay, mayroong clay dito, the same as argillic, but mas maraming sodium accumulation itong natric compared to the argillic. Okay, so in this example, so we have the natric accumulation. So natric accumulation in B horizon. At sa B horizon, tingnan to, mayroong mga column, no? Pinawid na columnar structure, columnar arrangement of soil particles. So sa columnar structure na ito, dito for example, mayroong column na gano'n ng lupa. Sa taas, mayroong mga puti na mga sodium cap. These are sodium, no? The sodium caps on the column of the soil particle is because of the high evaporation rate. Particularly these mga natric subsurface horizons can be observed in the arid region, no? Sa Saudi Arabia, because mainit, so ang evaporation is mataas. So thereby, the water moves upward into the atmosphere. Yung mga sodium na dala ng tubig, maiwan doon sa lupa. Pag angat ng tubig, ang tubig going to the atmosphere, but the sodium, hindi naman madala yung sodium sa atmosphere, so maiwan doon sa cap ng yuta as columnar structure of the soils. Later on, we have to discuss the different structure of the soils, no, and as well as texture. But this time, we just be sufficed with this discussion for the natric. Well, natric, the same as clay accumulation in the subsurface horizon, but must have more than 15% exchangeable sodium in the surface. Another example, you have the spodic. Spodic is the alluvial accumulation of oxides of aluminum and iron. Meaning to say, mayroong iron oxide, aluminum oxides, and these are called Siskey oxides. Okay? Okay. Those, again, spodic, alluvial accumulations of oxides of iron and aluminum or Siskey oxides, and also organic matter. So alluvial accumulation of organic matter. This must be a red or dark red in color, only found in acid sandy soils with high rainfall, generally found below E horizon, contains a BHS or the BS horizon. Now, if you are to look at the layer of the soil profile, for example, the soil profile, look at this one. I guess you have to change the order now. Anyway, so actually, ang A horizon is lighter in color, no, compared to both up, below and above. Okay, again, BS and BHS. So we have the BS in here in this particular region. So the BS refers to a spodic or the accumulation of oxides and aluminum oxides. Uh, Usually soils with a spodic diagnostic subsurface horizons, this belongs to an old soils. The soils has been through a long period of withering. Because if you can recall during our first topic, so the major and the final product of withering is the oxides and hydrous oxides of aluminum and iron. So soils with spodic categorically has less productive and less fertile soils because they're acidic and old soils. Right. So another examples we have of the diagnostic subsurface horizon, we have oxic, a very withered layer of iron and aluminum oxides. Now, itong mga lupa na mayroong oxic, mas old ito kumpara sa mga lupa na mayroong spodic. But these are old soils din, no? The oxics, very withered layer of iron and aluminum oxides, and 1:1 clay minerals, low in pH. These are acidic, not very fertile because mga tigulang na, found in tropical soils. And this is designated by BO in its soil profile. So in our example, look at this one, old withered soils in Hawaii, although we can also observe soils in Philippines, no? Sa ato, even sa dito sa, siguro sa Davao Oriental, merong mga ganito, makita natin, meron eh. Nung umakyat kami doon sa Hamigitan, may nakita ako ng mga lupa na ganito. Okay? Really soils. So, pula, because rich in iron and these are acidic soils, no? So, take note for that. And look at the thickness of the soil profile. Medyo lawom na siya, no? This is maybe more than 150 centimeters, more than 1.5 meters ang layer ng soil because mahabang panahon na nag-withered ito. So, makapal na lupa ang na-form na to a period of withering. So, this is oxic, no? Mga tigulang na mga yuta, matatandang lupa na ito. So, another one that we can observe in the diagnostic subsurface horizon is the cambic, no? This is slightly altered layers, not withered enough to be argillic, glacial argillic, represented by BW in the horizon, such as, for example, in this picture, right? B horizon designations or development of color and or structure. So cambic usually is mayroong lime, no? Mayroong lime. An example, mayroon tayong soil name in here. Inceptisol soils, tawag ito is lithic euthrocrypt. So belong to Inceptisol order. The lithic euthrocrypt. There's an example. Sa horizon, mayroon ditong A horizon. Dito sa baba, mayroong B horizon. Kung titingnan mo, hindi pa ito gaanong old na soils. Mga bata pa itong soils because mayroong lupa. After that, mayroong mga bato. Meaning to say, the rocks has not been withered fully. Maybe this has been through a short period of withering. Okay, this is cambic. Also, there are some instances that we cannot C, any diagnostic subsurface horizon in the B or in the C horizon. There are some different subsurface horizons, but for the purpose of this discussion, so you have just to present a few of that. Then I will leave it on to you to read all of the diagnostic subsurface horizon. Marami pa kasi. Okay, anyway. So I'll just give you a copy for that. Okay, so this illustration will aid ourselves in memorizing the different subsurface diagnosis horizon. Okay, so the first thing you have to memorize is the argillic. Compared to argillic, when it is less developed, then it must be convex. Compared to argillic, if it has more aluminum and iron compared to argillic, it must be spudic. When it's very withered, compared to argillic and compared to spudic, it must be an oxic diagnostic subsurface horizon. Compared to argillic, if it has a natric more than 15% sodium, it must be considered as a natric. Okay, that is how we aid ourselves, we help ourselves in memorizing some of the diagnostic subsurface horizons that can be observed in the B or either in the C horizon. All right. So I guess we have to stop at this portion, and then we'll proceed later on the succeeding topic para meron tayong breather and we can relax. So yeah, no, we have different diagnostic horizons. We have the Epipedons. Under Epipedons, we have mulic, ombric, ostic, histic. Yun. And we also have the diagnostic subsurface horizon that can be observed on the B horizon. We have the argillic, natric, cambic, spudic, and many others. Okay. So I guess we have to stop up to that, and we have to proceed later on the next topic, still on the soil classification. Okay, thank you.